Welcome! In this particular video, we'll be solving trigonometric equations involving cosine part 1. Let's take a look at our first example. Example 1. Solve the equation given below for theta greater than or equal to 0 but less than 2 pi. Our equation is -3 is equal to -5 plus 4 times cosine of theta. So the first step is to isolate cosine. To do so, let's start off by adding 5 to both sides of the equation. Now we get that 5 minus 3 is 2. That is equal to, this cancels, so you get 4 times cosine of theta. Now to isolate the cosine, let's divide by 4 on both sides. So this gives us that cosine of theta is equal to 2/4. Or after we divide both numerator and denominator by 2, we get that that is 1/2. So cosine of theta is equal to 1/2. Now, using the fact that x is equal to r cosine of theta, and on the unit circle the radius is equal to 1, we have x is equal to 1 times cosine of theta, or simply x is equal to cosine of theta. What we're looking for are for any x coordinates that will be equal to 1/2. So we're looking for the angles that will have such coordinates, okay? So if we look at the unit circle, let's look for points that have x coordinates equal to 1/2. Well, here's one of them. And here's the other one. So the angles that will make that a true statement will be pi over 3 and also 5 pi over 3. Therefore, theta is equal to 5 pi over 3 and pi over 3. So let's see one more example. Example 2. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So once again, the first thing we want to do is to isolate the cosine. In this case, let's go ahead and subtract 3 from both sides of the equation. So we get that 6 plus square root of 2 over 2 minus 3 is equal to cosine of theta. Now, let me multiply this one by 2 over 2 so we can get the same denominator. By doing so, we have that this becomes 6 plus the square root of 2 over 2 minus 3 times 2 is 6 over 2, and all of that is equal to cosine of theta. Now, rewriting this expression on the left one more time, we get that this becomes 6 plus the square root of 2 minus 6 all over 2 is equal to cosine of theta. Now notice that the 6 and the -6 cancels out, so we end up with cosine of theta is equal to the square root of 2 over 2. And now recall that x is equal to r cosine of theta, and on the unit circle the radius is equal to 1, so we have x is equal to 1 times cosine of theta, or simply x is equal to cosine of theta. So let's look for the points that have an x coordinate equal to root 2 over 2. By looking at the unit circle, we're looking for the x coordinates, or the points with x coordinates, the square root of 2 over 2. We notice here's one of the points, and the reflection across the x-axis will satisfy that as well, so here's the other point. Now, in order for us to solve this equation, we're looking for the angles that have such x coordinates. So those angles here happen to be pi over 4 and 7 pi over 4. So theta could be either one of those values, pi over 4 or 7 pi over 4. And those are your so-called solutions. So that concludes this particular example and this particular video. Thank you for watching, and have a wonderful day.